GeopByte.
Look at this problem. Asking like this. The mass of a planet is 1/10 of the mass of the Earth. Mass of the planet is mass of the Earth divided by 10. And its diameter is half that of the Earth. Radius of the planet is half of the radius of the Earth. So diameter half means radius also half. The acceleration 10 due to gravity. Acceleration due to gravity on the planet is. So acceleration, we are asked to decide what is the acceleration due to gravity on the planet. Now, for that, as you know, the acceleration due to gravity, G equal to general formula, G equal to G m by r square, G m by r square. Now, the no, G dash, G dash equal on the planet, G mp by rp whole square. It is equal to G. Of course, this value is given 10 meter per second square. MP equal to what? M by 10 divided by RP, R by 2 whole square. Simplify it. It is 1 by 10 GM divided by R square by 4. 4 goes up, 4 by 10, 4 by 10 GM by R square, GM by R square. It is 4 by 10, GM by R square approximately, GM by R square approximately 10. Here it is approximately 4 meter per second square. So here 4, option C may be correct. Option C may be correct. It is closer to that value. Because if I take the G value, if G equal to 9.8, then the G dash may be 4.2. G dash may be what 3.92 meter per second square. Understood clearly? Anyhow, option C is absolutely correct. Okay? No? Yes. Similarly, let us take the another important problem. Okay? Look at the screen. It is asking like this. The minimum energy required to launch a satellite of mass m from the surface of the Earth of mass capital M and radius capital R in a circular orbit at an altitude 2r from the surface of the Earth is given that mass of satellite is small m. Mass of the Earth is capital M. Radius of Earth is given capital R, and it is the satellite is sent to a circular orbit at an altitude h equal to 2r. Altitude h equal to 2r. Okay. Then what you are asked to find? What is the minimum energy? What kind of energy is required? Kinetic energy. Kinetic energy required is how much for launching the satellite? For that, you can use the conservation of energy principle from conservation of conservation of energy. Energy is coming under conservable quantity. Means total energy, total energy at the earth surface is equal to total energy at that altitude, at that altitude. Okay. The total energy at the earth surface is Ki plus potential energy Ui is equal to Kf plus potential energy Uf. Ki you need to find. Initial potential energy equal minus Gm by R equal to Kf half into m into v square plus plus but right, I can say final velocity square minus gmm by capital R plus h. Now you simplify it. Otherwise, let us take another slide. Ki minus gmm by R equal to kf half into m into v final whole square equal to gm by r plus h. R plus h. So v square, v half m g m by r plus h minus g m by r plus h. Ki minus g capital M small m by r equal to half into m into gm by, here h equal to 2r. It is given h equal to 2r, then r plus 2r, 3r. Directly I put minus gm m by 3r. Now you simplify it. Ki minus g capital M small m by r equal to, here it is 1 by 6 g capital M small m by r minus g capital M small m by 3r. Right, 3r. Now here it is. Let us simplify it. Let us take LCM. It is 6 g m by r minus 2 g m. It is equal to minus 1 by 6r g capital M small m. Then the energy, initial energy equal to minus 1 by 6 g m by r plus g m by r. We simplify it. It is minus g m plus 6 g m by r. Now you simplify it. It is 6r. 5 by 6 g m by r. That is the energy required for launching the satellite. 5 by 6 gmm by r. 5 by 6 gmm by r. Get the option D. Option D is absolutely correct. It is the most expected problem as a repeating problem. That's why I'm asking. This is the 5-star problem. Means this kind of problem can be repeated. Okay. Similarly, let us take the another important problem. Asking like this. The escape velocity of a body on the Earth's surface is 11.2 km per second. Escape velocity given 11.2 km per second. If the same body is projected upward with a velocity 22 km per second, if the velocity is becoming 22.4 km per second, the velocity of this body at infinite distance from the center of the Earth. Velocity of the body at the infinite distance from the center of the body, center of the earth is how much? As you know, square of the velocity at the infinite distance is equal to v square minus v square, right? So v infinity whole square equal to v 22.4 whole square minus 11.2 whole square. Then the velocity at the infinite distance from the center of the earth is root over, it is 22.4 whole square minus 11.2 whole square. You simplify this value for getting 11.2 into root 3. Unit is kilometer per second. So look at the options B. Option B is absolutely correct. Okay, na? Very simple problem. Similarly, look at the another important problem. Asking like this. If R is the radius of the earth and g is the acceleration due to gravity on the earth's surface, then mean density of the earth is, as you know, the acceleration due to gravity equal to g m by r square. But what is the density? Listen carefully. Here density rho equal to mass by volume. From this, mass of the earth equal to density multiplied by volume. Density multiplied by volume of the sphere is 4 by 3rd pi r cube. Let me put that value. G equal to G, M equal to rho into 4 by 3 pi r cube, 4 by 3 pi r cube divided by r square. 1 r square is cancelled. It is G equal to rho into G into 4 by 3 into pi into r. From this, the average density of the earth is 3G by 4 G pi r. 3 by 4 G 3 by 4, 8 minute. This okay. So equal 3 by 4 G 3 by 4, 8 minute. It should be 8 minute. Be very careful. G equal to rho equal to 3G by 3G by 4 pi GR. 3G by 4 pi GR. Look at the option A. Option A itself is absolutely correct. Okay, understood clearly? Yes.
GeopByte.